Hello and welcome back to our Eurocode7 class. Let's try to continue the class with the chapter number 8, slope stability, embankment, and hydraulic failure. So this time we are going to work on these two, hydraulic failure, and summarize the chapter. And then from next time, we will try to do some examples, applications, okay? So we will cover this hydraulic failure, everything, and summary of key point. So the first point we will go with is the overview and definitions. What is hydraulic failure? You can see some dams here and water coming out from the other side, the downstream, which is not normal, which is abnormal. So this is dam failure and hydraulic failure of dams. Okay, these are just few examples. So we are going to see some definitions of what is hydraulic, different type of hydraulic failure, and see how to, what is Eurocode saying about these failures, how to design the dam so that this type of failure cannot happen, okay, to prevent the failure. So this is the objective of this lesson, okay. So the provision of this section apply to 4 mode of ground failure, okay, induced by poor water pressure or poor water seepage. And we have failure by uplift, okay. We will define all of them soon enough, don't worry. Next, we have failure by heave. And we have also failure by internal erosion, okay. And we have failure by piping. So these are mainly hydraulic failure we have. So each of them, you need to know how they work, and you need to know how to design the dam or any embankment to prevent them from happening, okay. So let's go one by one, the definitions. So the hydraulic failure in Europe, according to Eurocode, these are the definition. First, the uplift failure. Uplift is just pushing up, okay. So this failure happen when poor water pressure under the structure, under the dam, for example, or we have sometimes low permeability ground layer become larger than the mean overburden pressure. It's very simple. It means the pressure of water under the dam is higher than the weight of the dam itself. Technically, this is the meaning. So it leads to loss of equilibrium, and this can cause the structure like gravity dams to lift or overturn. It can destroy the dam completely, okay. So I will explain in detail what this means. You have here a, let's say, gravity dam, okay, which is under the dam you have water pressure, okay. These are the water pressure. I think all those who study soil mechanics, maybe 2 or even 1, soil mechanics 1, yeah, water in the ground, you will be able to understand this, okay. So it means everything you studied in soil mechanics will help you here as well, okay. So the pressure is not uniform under the dam, okay. upstream here, pressure is higher than here. Okay, and it depends on the amount of water, the height of water here. You can see H1 and the amount of water here, H2. Sometimes this H2 can be 0, okay? Yeah, but not always. So H here, the pressure here and here are easy to obtain. You can see here. But Hx, it means pressure at any given point is obtained using this equation. Okay, so X is here, the x-axis. So you can determine the pressure at each position. But anyway, we will come back on this kind of thing, the calculation. But what is important here for you to understand is that the pressure, water pressure here under this heavy dam, the gravity dam, sometimes is much higher than the weight of the dam itself. So in that case, it will push up and destroy the dam completely. This water pressure here is when there is no drainage system under the dam, because sometimes to reduce the pressure, we can do drainage in the dam to reduce it. This is an example here, the case where the drainage exists, drainage system exists, and you can see this drainage system here. In that case, you can see here the pressure is high, but because of this drainage system, the pressure reduces here, and it will decrease gradually up to the end here. Okay, so in this case, the H1 is similar to this one, pressure, water pressure here, and H2 not same, but this H3 means here this distance, H3, you need to calculate it. It depends on the position of this one, of the drainage. This is drainage gallery. So it means human can enter inside actually. Okay. So it calculated depending, you can see X here, this small distance. And this case is when this distance is very small. You can see when X is less or equal to 0.05 times H1. H1 is here, the water level here, head of water head. So you have several cases, but we will come back on these calculations when we will start some examples, okay? Because these calculations will enter, you will need them to estimate, to check if the failure against uplift is satisfied, okay? Yeah, this is one of the way dams, not only gravity dam, but even earthen dam can fail, okay? So this is example of gallery, and you can see people drilling foundation drain. They are making a drain to reduce the water pressure under the dam, okay? So in the gallery of concrete gravity dam, this will relieve the uplift pressure under the dam, okay? And here is a photo showing some how the monitoring of the uplift pressure is conducted, okay, at the foundation drain in the gallery. Okay, you can see the gallery, it can, it's large enough to allow people to enter. Okay, now I'm going to show you some example of failure, dam failure, due to uplift, due to water pressure. All the following dams I'm showing were reported to be damaged. They failed because